constant retarding force of 50 Newton is applied to a body of mass 20 kg moving initially with a speed of 15 meter per second, how long does this body takes to stop? So what is the question? Here a body of mass 20 kg is initially moving with a speed of 15 meter per second, and we are applying 50 Newton retarding force so that it stops. So they are asking how much time will it take to stop. So what is the force? F is equals to 50 Newton. And what is the mass of the body? Mass is 20 kg. And they have given initial speed is 15 meter per second. How long does it take to stop? So using F and M we can find acceleration. Acceleration is equals to force by mass. So 50 by 20. And as it is a retarding force, you can take it as minus 2.5 meter per second square. Now we know acceleration, we know initial velocity, and we know final velocity. They are asking how much time it takes to stop. So that means final velocity is 0. So using V is equals to U plus AT, we can get what is the time. V is 0, U is 15, acceleration is minus 2.5 meter per second square and time. So it is 15 by 2.5. It will be minus 15 by minus 2.5, that is equals to T, that is equals to 6 seconds. A 5 kilogram block is acted upon by two perpendicular forces 8 Newton and 6 Newton. Find the magnitude and direction of acceleration produced in the block. Okay. So here there is a block whose mass is 5 kilogram, and we are applying two perpendicular forces, that is 8 Newton and 6 Newton. Suppose we are applying 8 Newton in this direction and 6 Newton in this direction. Then they are asking what is the magnitude and direction of acceleration produced in the block. So before that we have to find what is the force. So this is 6 Newton and this is 8 Newton. We know force is the vector quantity. So we have to do vector addition. So if they are perpendicular to each other, then what is the vector addition? It is root over F net. Root over F1 square plus F2 square. That is 6 square plus 8 square. That is equals to 36 plus 64. That is equals to root over 100. That is equals to 10. So this is the net force. And how will be the net force? It will be in this direction. Okay. Now we can find the value of acceleration. We have force, we have mass. So acceleration is equals to F net by M. F net is 10 and mass is 5 kilogram. So that is equals to 2 meter per second square. So they are also asking the direction of acceleration. So let us find the direction of acceleration. If suppose this 8 Newton is making angle theta with the resultant force, this is resultant force, then we can use cos theta. Cos theta equals to, it is adjacent by hypotenuse. What is the adjacent here? It is 8. What is the hypotenuse? It is resultant force, that is 10 Newton. 8 by 10. So what is that? That is 4 by 5. And we should know cos inverse 4 by 5 is 37 degree. So this is to be kept in mind. For cos inverse 4 by 5 is 37 degree. Sin inverse 3 by 5 is also 37 only. The driver of a three-wheeler moves with a speed of 36 km per hour, sees a child standing in the middle of a road and brings his vehicle to rest in 4 seconds just in time to save the child. What is the average retarding force on the vehicle? How far was the child from the three-wheeler when the brakes were applied? And given the mass of the vehicle is 400 kg and driver is 65 kg. So there is a three-wheeler vehicle, and it is seeing a child standing here. So its initial velocity is 36 kilometer per hour. 36 kilometer per hour is 36 into 1000 by 3600 meter per second. So it is 10 meter per second. So that is his initial velocity. Initial velocity of the three-wheeler is 10 meter per second. U is 10 meter per second. Now, um, so he is seeing the child and brings his vehicle to the rest in 4 seconds. So, time taken to stop is 4 seconds. To stop, that means the final velocity is 0. So, V equals to 0. They are asking what is the average retarding force. So I have U, I have V, I have T. From this easily I can find acceleration, and I have also mass. So using that I can find the force. So let me find acceleration first. V equals to U plus AT. Now what is V? It is 0. What is U? It is 10. Plus A is, that is we have to find, time is 4 seconds. Now A equals to minus 10 by 4, that is equals to minus 2.5 meter per second square. Why it is minus? It is retardation. So we are finally stopping it. That means there is some retardation to stop. So that is why we are taking minus 2.5 meter per second square. So they are asking what is the retarding force on the vehicle. So force is equals to mass into acceleration, that we know. We have acceleration. What is the mass? We have to take the total mass of vehicle and the driver. That is, what is the total mass of vehicle and driver? That is 400 plus 65. So it is 465. That is the mass. Acceleration is 2.5. That is minus 2.5 meter per second square. So this multiplication we get minus 1162.5 Newton. This is the retarding force, average retarding force on the vehicle. So next question is, how far was the child from the three-wheeler when the brakes were applied? So suppose the initial distance when the driver is seeing the child is this much, okay, then it took 4 seconds to stop. That means he would have come up to this point, and then he is stopping here. Suppose he is stopping here. So initially it was at this distance, this distance, this distance. So they are asking what is this distance. So how far was the child from the three-wheeler when brakes were applied. So here he has applied the brake, and it took some time and it stopped here. So initial distance means we have to take this distance. So what we can use, we have U is equals to 10 meter per second, that we have. V equals to 0 meter per second, that also we have. Acceleration is also minus 2.5 meter per second square, that is also the known quantity. Now they are asking the distance. We can use V square minus U square equals to 2AS in this case. So V square is 0 square minus U square is 10 square, that is 100, that is equals to 2 into what is acceleration? It is minus 2.5 into S. So from this we can calculate S. S is equals to 100 by 2 into 2.5, that is 5. So that is equals to 20 meters. So initial distance between the that is a three-wheeler and the child is 20 meter. Let us see this question. A rocket with a lift of mass 20,000 kg is blasted upwards with initial acceleration of 5 meter per second square. Find the initial thrust of the blast. Take G equals to 9.8 meter per second square. So they are giving the lift, the mass of the lift in the rocket, that is 20,000 kilograms. So we are having mass in our hands. So what is the initial acceleration is also given 5 meter per second square. So it is blasted upwards. That means acceleration is in the upward direction. So they are asking the initial thrust on the blast. Okay. So this question is similar to the case of a lift. Okay, when the lift is moving upwards, we take acceleration is in the upward direction. So same like this, and mg is acting downwards. So mg is acting downwards. Here mg is nothing but 20,000 into g. Okay, acceleration is in this direction. uh, what else we have? Then we have to find the reaction force, and that is what is being asked. Now we know net force is equals to mass into acceleration. What is the net force? How will we write the net force? Suppose uh, so in this way reaction will be there, because passengers, if passengers are standing in the lift, we know the reaction will be in this direction. Now we can write r minus mg equals to m into a. So r is equals to m into g plus a. So this will give the reaction force or the initial thrust of the blast. So what is m? That is 20,000. What is g plus a? It is 9.8 plus initial acceleration is 5 meter per second square, that is 20 into 10 power 3 into, this is 14.8 meter per second square. So this is equals to, on multiplication we get 2.96 into 10 power 5 Newton. So this is the initial thrust of the blast.